Okay, I'm looking at the problem we examined on Saturday, the one on the screen up here now. And if you recall, we were looking to find the open circuit voltage. And as a result, we decided to change the circuit from this to this because the inductor doesn't have any current flowing through it, so it has no effect on the voltage between A and B, and so we can just ignore it and look at the voltage across the capacitor. And we did the KVL for the current, and we found that the overall current IX was 2.381 angle 61 degrees milliamps. And from there we could just multiply the impedance of the capacitor by that current, and we could get a Thevenin voltage of 0.344 at an angle of minus 29.01 degrees. Now, somebody asked during class how to do that using LTSpice, and I've spent quite a bit of time trying to figure that out, and it's not straightforward. But I have finally got a solution that works, right? And it gives us the same answers. So let's have a look at what I did, right? So here's the circuit, and we've got the capacitor, we've got the resistor, we've got the source. Let's just see what I did to the source, right? I've still kept it at a DC value, but I've set the DC value to 0, and you can see here there's a small signal parameter, and I'm going to set the amplitude to 20 and the phase to 60 degrees, which is what our voltage source is. Now, this allows us to use a different sort of analysis, not the .op and not the .trans, the operating point and the transient analysis. This allows us to do what's called an AC, or alternating current analysis, in LTSpice. Okay, so you can see down here the list, the way to run an LTSpice AC analysis. Instead of .op or .tran, it's .ac, and then a list of the frequencies you want to run it at. Now, before I go through that, let's just have a look. The problem we had was finding a current dependent voltage source. And the example that a student came up with used a BV style of thing. And I found it wasn't giving the right results. There is actually an explicit current dependent voltage source, and it's called an H1 type, right? Just a H type. And what you've got to do is you've got to give it two parameters. You've got to give it the voltage, rather the component where you're measuring the current, and the gain that you put on that current, right? So in our case, the gain is 2800, and you'll notice I've got this Vmes. So, and you'll also notice that there's an extra component that I've had to add to the circuit. And I couldn't figure out how to measure the current through C1 using just I of C1, or rather, it didn't, the H1 device, if I put C1 here, maybe I should have put something other than C1, but I couldn't get C1 to work. In fact, let's just, yeah, I'll try that later. So anyway, what that does is it measures the current through Vmes, and let's just have a look at Vmes. Vmes is a 0 volt source. So that it's not adding any voltage to it, but it will allow us to measure the current through, or at least will allow the H device to measure the current through it. And if I run that and select the voltage across C1, then I get this plot, and you'll notice that my AC analysis is at 3 different frequencies: 499 Hz, 500 Hz, and 501 Hz. The reason I did that is I couldn't get LTSpice to pop up this measurement window, the cursors window, without having 3 separate, or at least more than one frequency. The frequency we're interested in is 500 Hz. Okay, so we're doing that, and if we look at the 500 Hz and read the numbers, the voltage across the device, which is going to be our Thevenin voltage, is 344.4 millivolts, and the angle is minus 29.01, and you can see down here that that's what we got in our Thevenin voltage calculation and analytically. So that's the way to do it. I will put the information about the file that I used up on Blackboard. Actually, I'll put it in YouTube, and I'll put it in the content or materials channel in Discord. Okay, that took a lot longer than I thought it would, so I'm not surprised things didn't quite work out. So, but this does work out, and the other thing we can check is the current. So I'm just going to kill that and rerun it, and this time measure the current, right? And I've got to select the linear numbers so we can get it, and then click on there to get the cursor and the values, and it's 2.3806, and if we scroll up, the number we got was 2.381, angle 61 degrees, so that all works pretty nicely as well. Okay, so that is how to use LTSpice for the question we looked at in class on Saturday.